An X2.2 solar flare eruption, like the one recently observed, is a major event in space weather that can have significant and widespread effects on Earth. Solar flares are sudden bursts of energy from the Sun, releasing vast amounts of radiation and charged particles into space. An X-class flare, especially one of the X2.2 magnitude, is among the strongest types of solar flares. This intense burst of energy can disrupt several key systems on Earth and in space. The most immediate impact is on communication systems. High-frequency radio signals, especially those used in aviation and maritime communication, are often severely degraded or completely blocked, particularly on the sunlit side of the Earth. This is due to the ionization of the Earth's ionosphere, which affects radio wave propagation. GPS satellites are another vulnerable target. The flare's energetic particles can interfere with the satellite signals, potentially leading to inaccuracies in positioning data. This can impact everything from navigation apps on smartphones to precision systems used in scientific research and military operations. Power grids, especially those in high-latitude regions, may experience voltage fluctuations or even damage due to the influx of charged particles hitting the Earth's magnetosphere. These disturbances can induce geomagnetic storms, which might lead to electrical surges that could harm transformers and other vital components of power infrastructure. On the upside, such flares can lead to stunning auroras or the northern and southern lights. These spectacular light displays are caused by solar particles colliding with atoms in Earth's atmosphere, creating bright, colorful glows. However, this week's flare might push these auroras to latitudes much lower than usual, giving more people a chance to witness the phenomenon, but also increasing the chances of geomagnetic disruptions. Astronauts in space and high-altitude flights could be at risk due to the elevated levels of radiation from the flare. The increased radiation poses a health hazard to those outside Earth's protective atmosphere, and airlines may need to reroute flights, especially those near the polar regions where the radiation is more concentrated. The effects of an X2.2 flare are typically short-lived, lasting anywhere from a few hours to a couple of days. However, the occurrence of such an event is a reminder of the dynamic and powerful nature of the Sun and the importance of monitoring space weather to protect infrastructure and human health.